Good morning, everyone. Myself, Ankita Deshmukh, Assistant Professor from Saraswati Institute of Pharmacy, Kurtadi. Today, we are delivering the topic Emulsion from subject Industrial Pharmacy. In that, we can see the following contents. First one is the definition of emulsion, second is the classification and type of emulsion, then application of emulsion, then formulation and preparation of emulsion, and last one is the identification test. Then the classification. Firstly, we can take the brief review on the classification of dosage form, in which our emulsion is present in which class of dosage form. There are mainly four classes of dosage form. First one is the solid dosage form, second is the semi-solid dosage form, third liquid dosage form, and last is the gaseous dosage form. In first solid dosage form, there are mainly two classes. First is the unit dosage form and second is the bulk dosage form. In unit dosage form, there is a tablet and capsules are present. In bulk dosage form, there is a powders and dusting powders are present. In semi-solid dosage form, the cream, paste, ointment, gels, and suppositories are present. In liquid dosage form, there are classified into two classes. First is the monophasic liquid dosage form and second is the biphasic liquid dosage form. In monophasic liquid dosage form, there is a syrup and solution are present. In biphasic liquid dosage form, there is a emulsion and suspension are present. In last gases, the inhalers and aerosols are present. Next, we can see the introduction and definition of our emulsion. First is the definition. An emulsion is a two-phase system consisting of two incompletely miscible liquids, one of which is dispersed as finite globules in the others. Means, firstly, we can see the emulsion is a biphasic liquid dosage form, means in which there is a two phase are present. First one is act as a finite globules into the another phase. Next, the particle size of globules ranges from 0.25 to 25 micron meter. Means in that the particle size of globules which is present in range of 0.25 to 25 micron meter. Next, for the preparation of emulsion, most important ingredient is the emulsifying agent. Next, we can see the classification of emulsion. Mainly, emulsion are classified into mainly three classes. First one is the dispersion according to the dispersion phase. Second one is the according to the particle size, and next one is the mode of action. In first dispersion phase, according to the dispersion phase, there is two classes of emulsion. First one is a simple emulsion and second one is the multiple emulsion. In simple emulsion, there are two classes or two type of emulsion are present. First is O by W type of emulsion and second is W by O type of emulsion, and next one is the multiple emulsion. According to the particle size, again there are two classes subclasses. First one is the micro micro emulsion and second is the macro emulsion. According to the mode of action, there are various types of emulsion are present. First is the topical, rectal, oral, and parenteral emulsions are also present. There are mainly four classes of emulsion. We can see firstly the O by W type of emulsion. In O by W type of emulsions, in which oil is present in disperse phase and water is present in a dispersion medium or present in a continuous phase. In Oil in water type of emulsion, there is a two phase. First one is oil phase and second is the water phase. That is it is the biphasic liquid dosage form. Therefore, in that there is a two phase are present. First is oil phase and second is water phase. In O by W type of emulsion, oil is present in a disperse phase and water is present in a continuous phase. It is O by W type of emulsion. It is preferred for internal preparation, internal dosage form as well as the external use external use application. Then in O by W type of emulsion, water is present in continuous phase or present in a large quantity. Therefore, it is a non-greasy and easily removable from the skin. Example of O by W type of emulsion for external use, that is the vanishing cream. Next one is the W by O type of emulsion. O by W by O type of emulsion, in which water is present in a disperse phase and oil is present as a dispersion medium, or it is also called as the continuous phase. In W by O type of emulsion, water is present in disperse phase and oil is present in continuous phase. In that in W by O type of emulsion, there is oil is present in large quantity. Therefore, it is a greasy in nature and not water washable and it is mostly used for external application only. Example of W by O type of emulsion is cold cream. In third class, multiple emulsion. There are two classes are present, in which first, first emulsion is water in oil in water and second is oil in water in oil. In water in oil in water system, and oil phase separate internal and external aqueous phase, and in oil in water in oil system and water phase separate internal and external oil phase. Next class is according to the particle size of globules of emulsion, in which the particle size of globules are present in range of 0.2 to 50 millimeter. Those emulsion are called as the micro emulsion. Sorry, those emulsion have the particle size in range of 0.2 to 50 millimeter. Those emulsion are called as the macro emulsion, and the particle size is between 0.01 to 0.2 millimeter. This emulsion is called as the micro emulsion. There are the examples are pharmaceutical emulsion, in that the gelocil are present. Then next one is the pharmaceutical application of emulsion. For unpleasant drug, medication or drug, we can prepare the emulsion. Next is the oral, rectal and topical administration of oils and oil soluble drug. Next, absorption and penetration of medicament and enhanced. Next, water soluble drug or vaccines to provide slow release. These are the pharmaceutical application of emulsion. Next is the formulation of emulsion. For the formulation of emulsion, there are various types of ingredients are present. Firstly, the emulsifying is most important for the preparation of emulsion. Next is the preservative, flavoring agent, coloring agent are present in the emulsion. First, we can see the emulsifier or emulsifying agent. What is the role of emulsifying agent? Emulsifying agent is any material that enhances the stability of emulsion. Emulsifying to enhance the stability of emulsion, the emulsifying agent are mostly used or to prevention the collisions of particles. The emulsifying agent are used. Then we can see the ideal properties of emulsifying agent. It is colorless, odorless, tasteless, non-toxic, non-irritant, and able to produce a stable emulsion at low concentration. And we can see the various types of emulsifying agent in that carbohydrate material examples are acacia, tragacanth, agar, pectin, oak by W type of emulsion. These emulsifying agent are used. Second is the protein substances in that gelatin, egg yolk, casein are used. Next, high molecular weight alcohols in that stearyl alcohol, cetyl alcohol, and cholesterol are used. Next is the wetting agent in that anionic, cationic, and non-ionic wetting agent or surfactants are used. Ionic surfactant examples are SLS, and cationic uh, surfactants examples are ammonium bromide, and non-ionic surfactant example are span 80 and 20. And next is the finally divided solids. Examples are bentonite, magnesium hydroxide, aluminum hydroxide. Next is the preservative. The preservatives are used for to inhibit the growth of microorganisms or to prevent the contamination of emulsion. Examples of preservatives are benzoic acid, salicylic acid, benzalkonium chlorides, etc. Then we can see the preservative used in emulsion. They must have the following ideal properties. The preservative are less toxic, chemically stable, reasonable cost, acceptable odor, taste and color. They are effective against fungi, yeast and bacteria, and stable to heat and storage condition. These are the ideal properties of preservatives. Then next is the antioxidant. Antioxidants are used for to inhibit the oxidation of emulsion. Antioxidants are the compound that inhibits the oxidation of emulsion. Then we can see the firstly oxidation. What is meant by oxidation? Oxidation is a chemical reaction that can produce a free radical, thereby leading to chain reaction that may damages the cell of organism. Example are gallic acid, ascorbic acid, etc. Then we can see the ideal properties of antioxidant. Antioxidants are non-toxic, non-irritant. It is effective at low concentration under the express condition of storage and uses. It is soluble in medium and stable. Next, antioxidant for use in oral preparation should be odorless and tasteless. Next is the flavoring agent. Flavoring agents are added in emulsion for to impart the taste of emulsion. Examples are vanillin and benzaldehyde. Vanillin in liquid paraffin emulsion. Vanillin are used. Benzaldehyde in cod liver oil emulsion are used. Next is the preparation of emulsion. The method commonly used to prepare emulsion can be divided into two categories. First is the trituration method and second is the bottle method. In trituration method, there are also two methods. First one is the dry gum method and second is the wet gum method. Then first is the dry gum method. In this method, the oil is first saturated with gum with a little amount of water to form the primary emulsion. In dry gum method, firstly we can take the oil and gum with a little amount of water and to form the primary emulsion. The trituration is continued till a characteristic clicking sound was heard and a thick white cream is formed. After that, the primary emulsion is formed. After, the remaining quantity of water is slowly added and the final emulsion is formed. The dry gum method follows the 4 4 is to 2 is to 1 formula, means 4 parts of oil are present, 2 parts of water are present and 1 part of gum is present. Next is the wet gum method. As the name self indicates that wet gum method. In this method, first gum and water are triturated together and to form the mucilage, and the quantity of oil then added in the mucilage in small proportion and thoroughly triturate to form the primary emulsion. Once the primary emulsion is formed, remaining quantity of water is added in emulsion and final emulsion was prepared or formed. Also, the wet gum method also follows the formula 4 is to 2 is to 1. That is, in that wet gum method, 4 parts of water is present, 2 parts of oil is present and 1 part of gum is present. Next is the bottle method. The bottle method is mainly used for the preparation of emulsion containing the volatile and non-viscous oils. Then, in this method, oil or water is taken in bottle and gum also taken and shaken vigorously. After that, the second liquid was added. Again, the bottle is shaken vigorously to form the primary emulsion. After that, more amount of water is added. Uh, Again, water is added in small portion and agitate it vigorously and to form the final volume of emulsion. Then procedure of bottle method. Firstly, we can take the uh, volatile oils or viscous oils and gum in a dry bottle, then shake it vigorously, then add a water and shake vigorously to form the primary emulsion. After that, the remaining quantity of water is then added into a primary emulsion, then we make make the final emulsion. Next is the identification test of emulsion. In that, first test is the dilution test. The test is based on solubility of external phase of emulsion. External phase means the disperse phase. If we can take the O by W type of emulsion and it is diluted with water, There is a no change occurs in O by W type of emulsion because water in continuous phase they are diluted with water, they are mixed with each other. But we can take the O by W type of emulsion and dilute it with water. There is no dilution occurs. In that phase there is a separate the two phases. Next is the dye test. When emulsion mixed with amaranth dye and observe the under the microscope. In a dye test, the water phase is absorb the dye. Therefore, if the continuous phase appears red, see in diagram. If the continuous phase appears red, then it is the O by W type of emulsion, means water absorb the dye. Therefore, it is O by W type of emulsion. And second, if the scatter globules or जो disperse globules appears red and continuous phase is colorless, then it is the W by O type of emulsion. Next is the fluorescence test. In fluorescence test, only oil phase gives the fluorescence under the UV light while water does not show the fluorescence. Therefore, O by W type of emulsion does not show the fluorescence while W by O type of emulsion gives the fluorescence under the UV light. Then next is the conductivity test. Conductivity test, in that water is a good conductor of electricity while oil is a bad conductor of electricity. Therefore, continuous phase of water runs the electricity more than oil oil continuous phase. See in first diagram, there is a O by W type of emulsion. In that, water is present in a continuous phase, therefore it can conduct the electricity, therefore the bulb is blow. In another diagram, there is a W by O type of emulsion. What oil is present in the continuous phase, therefore in that phase the electricity does not run, therefore the bulb is does not blow. Then next one is the instability of emulsion or instability in emulsion. What time we can say the our emulsion is stable? If the dispersed globules are uniformly distributed throughout the dispersion medium during storage, it is chemically stable. At the time of storage, there is no bacterial growth occurs. At that time, we can say the our emulsion is stable. The emulsion instability may either be reversible or irreversible. According to the instability, they are formed. Instability occurs in emulsion, that is cracking, flocculation, creaming, and phase inversion. Then first is the cracking. We can see the what is meant by cracking. Cracking means there is a separation of two layers, means that there is a separation of two phase, that is dispersion phase and continuous phase. Due to the collagens of dispersed phase globule, means collagens means there is a aggregation of dispersed phase, therefore the two phases are separated. Cracking may occur due to the following reason. First reason is the addition of emulsifying agent of opposite type. Second is the by decomposition or precipitation of emulsifying agent. Next is the by addition of common solvent. Next is the by microorganism. Next change in temperature, and last is the by creaming. Next phase is the creaming. In creaming, uh, there is a aggregation of globules are formed at the top of the emulsion or far down at the bottom of the bottom of the container and form the thick layer, but it is the reversible phase. We can shake it vigorously, then the emulsion is redispersed and the creaming is not found. Then the factors affecting creaming. First is the radius of globule, second is the density of dispersion medium and dispersing medium, then the viscosity, and next is the storage condition. Next is the phase inversion. Phase inversion. Phase inversion means there is a change of type of emulsion, means there is a change in O by W type of emulsion to the W by O type of emulsion and vice versa. Reason for the phase inversion means there is a change in type of emulsion. What are the reasons for the phase inversion? That is, first is the addition of electrolyte, second is the changing phase volume ratio, next is the temperature by changing temperature, next is the changing the emulsifying agent. These are the reasons for the phase inversion. These are the identification tests, uh, instabilities in emulsion. Then next part we will see in the next lecture. Thank you.